All right, let's talk Oracle. If you've ever written even a simple SQL query, you've used one of the most complex and powerful engines ever built. But what really goes on inside that black box after you hit run? Well, today, we're going to pop the hood and take a look around.
You know, this quote right here, it nails it. Think about it like this. A great mechanic can't fix a car by just randomly pulling levers. They need a mental map of the engine. It is the exact same deal for us when we're writing SQL. If you want to write code that flies, you've got to understand the machine it's running on.
So for this explainer, let's make it personal. I want you to picture one of your queries, maybe one you wrote this morning. We're going to treat it like the main character in an adventure story. We're going to follow its journey, step by step, from the second you hit execute all the way until the results land back on your screen. Okay, so our query's journey begins. The very first thing it encounters is this fundamental split, the two biggest concepts in the Oracle universe, the instance and the database. It's actually pretty simple. The instance, that's the brain. It's all the active memory and processes, the bustling, thinking part that does all the work. Then you have the database. Think of that as the bookshelf. It's just the physical files sitting passively on a disk. So when you connect, you're talking to the brain. The brain then goes to the bookshelf to get what it needs. And here's the kicker. This means pretty much all performance tuning happens right there, inside that active brain.
Right, so our query has entered the brain. Its first stop is this massive central hub of shared memory called the System Global Area, or SGA. You can picture it as a huge open-plan workshop that every single user connected to the database has to share.
And this shared workshop is where all the real action is. For our query's little trip, we're going to visit the three most important workstations inside this SGA hub.
So the very first place our query looks is the buffer cache. This is a giant pool of memory that holds copies of data blocks that were recently pulled from the disk. You can just think of it as the database's short-term memory.
Now, if the data our query needs is already sitting there in the buffer cache, bam! That's a cache hit. This is the absolute jackpot scenario. Getting data from memory is thousands of times faster than getting it from a spinning disk. This is the dream.
But what if the data isn't there? Uh-oh. That's a cache miss. And this is where performance just falls off a cliff. The database has no choice but to stop, go on a long, slow journey to the physical disk, and fetch that data. Honestly, this is one of the biggest culprits behind a slow query.
Okay, next stop for our query is the shared pool. And this part is just brilliant. Imagine a librarian with a perfect photographic memory. Before Oracle does any heavy lifting, it checks with this librarian to see if your exact query has been run before. And if it finds a match, it just reuses the old game plan, the execution plan, instead of having to figure it all out again. This saves a huge amount of work.
And our last little stop in the SGA is the redo log buffer. Now this one's all about safety. If our query is actually changing data, with an insert, update, or delete, a tiny record of that change gets written here first. It's a critical safety net. It makes sure that if the whole system crashes, no committed work is ever lost. So, up until now, our query has been hanging out in the SGA, that big public workshop. But some jobs, they need a bit of privacy. And for that, our query gets its very own private memory space, the Program Global Area, or PG. So if the SGA is that bustling shared workshop, the PGA is like a private, soundproofed office assigned only to our query. No one else can touch it. And this is where it does its own heavy, memory-intensive work, like sorting data when you use an order by or a group by clause.
And this is a really high-stakes operation. If our query needs to sort a huge pile of data, it needs a big enough PGA, a big enough office. If it runs out of its private memory, it has to spill that work over to temporary storage on the physical disk. And we know what that means, right? It's slow. Painfully, brutally slow.
Okay, one final critical component our query has to interact with. It's a super powerful mechanism that's part safety net and part time machine, all rolled into one. It's called the undo segment.
And this is where things get really clever. You might think undo has one pretty obvious job, but it's actually pulling double duty. It has two completely different but equally vital roles to play.
So on one hand, undo is for you.
It saves the before picture of any data you're changing so that if you make a mistake, you can just roll back and pretend it never happened. But at the exact same time, it's providing read consistency for everybody else. While you're in the middle of your changes, other queries can use that before picture to see a clean, stable version of the data. It's an absolutely genius trick to keep the database from descending into chaos.
So, let's wrap this journey up. What are the big performance killers we discovered? The things we absolutely have to watch out for. Number 1, cache misses, forcing those slow, painful trips to the disk. Number 2, PGA spills, when a big sort runs out of memory and also has to use that slow disk. And number 3, reparsing SQL, which forces the database to reinvent the wheel when it really doesn't have to. Avoiding these 3 is the name of the game.
So there you have it. A whirlwind tour, a map of the landscape inside the Oracle engine. We followed your query from start to finish. We saw where it goes, what it does, and what slows it down. Now that you know how the parts work together, the real question is, are you ready to start tuning that engine?